Good to have you back in my video again. So this time I'm going to solve the tomato solution, and in ISI Tomato B-Stat B-Math Coaching. This question is question number 95. So this has said the number of different factors of 1800. So 1800, number of different factors. Every number can be expressed as product of primes. So we are going to express it as product of primes. So this will be 2 to the power 3 into 5 square into 3 square. And the formula is that take the powers, add 1 and multiply for finding the total factors. That is 3 plus 1 into 2 plus 1 into 2 plus 1. In this case, the answer will be 36. Now, the 96 number question also is very similar. So find the factors of 3003. So you have to express in terms of this way, which I have shown you. This first will be 3 into 1001, and then 1001 can be expressed again, and you will get your answer. Okay. Now what happens for this is a little bit different actually. This is 31001, then 1001 you can see the guess is 11 into 91, and even 91 is 713. So here we run right 3 into 7 into 11 into 13. So the powers are 1 1 1 1. So we need to multiply 2 2 2 2 4 times. So the answer is 16. That is option D. Now next I will be solving with respect to primes. These are again a number theory based question, that is number theory. Question number 151. So they have given n equal to 51 factorial plus 1, and they have asked number of primes, find the number of primes among n plus 1, n plus 2 dot n plus 50. So how many primes will be there? So in order to make it prime, we need to show whether the numbers are composite or not. So now 51 factorial. This number is divisible by what? This is what? 1, 2, 3 dot 51. So this thing is divisible by 1, 2, 3, 4, 5, 7, 51, all the numbers. So 51 factorial plus 2 is divisible by again 2 to 51, all the numbers. Okay. So therefore all these numbers are divisible. Hence n plus 1 is a composite number. N plus 2 is also a composite number. In that way n plus 50 is also a composite number. So all these numbers are composite, hence it can be expressed as product of two numbers. So we can say that none of them is a prime number. Now next question is 154. It's about how many zeros at the end. So they have given an expression 1,000,000 and it exists with how many zeros at the end. How many zeros? So here in order to make zeros, as in my previous some of the videos I have already said that any factorial over 4 ends up with a 0. That is 120, 620, 7. Okay. Now, in this case, in order to find the zeros at the end, we have a formula. That is how a 0 is done. For example, 10 factorial. So 10, 9, dot 5, dot 2, 1. So this 5, 2 makes a 0 and this 10. So 10 factorial ends up with 2 zeros. So in the case of 100 factorial, it becomes problematic. So we have a very basic formula. We divide this basic question with the powers of 5. So we will proceed as the powers of 5 simply. And until and unless we get it more than the numerator, we will be proceeding. So that is 1000 by 125, that is 5 cube. Then 1000 by 5 to the power 4, 625. Now we can't proceed after this because that will be more than 1000. And here again we take the box function. That is, box function means we take the whole number only. So 1000 by 5 will give you 520. This will give you 40. Now 125 divided by 1000 isn't a very big number. 125 divided by 1000 exactly gives you 8. And 625 is 1. So fortunately in these cases we get a divisible part. So 200, 240, so answer is there are 249 zeros at the end of the expression which is given. Now a similar type of question they may ask is, this one is a very important note, and that says, in the expression of, for example, 248 factorial, find the highest power of 2, or maybe 3, or maybe 4, or maybe 5, like this. So how to do this kind of sums? So here, in this kind of expression, the highest power of 2, if it is given. So you just proceed the way we have proceeded in the last question and only just replace it by 2. 248, so this will be 2 square. 248 by 2 to the power 3, and then 248 whole to the power 2 to the power 4. 248 2 to the power 5, that is 32. 248 2 to the power 6, that is 64. 248, that is 128. But here the sum ends. Here the sum ends because 248 after this 256 which will be greater. So the answer is 124. 4 by this 4 6 are 24, 4 2 are 8. In that way you can get your sum and the sum of all these. Even in case of 3, or maybe just if I take it as 8 for example. So you divide 248 by 8, then 248 by 8 square, then 248, but 8 cube is more than this, so the sum ends up here. So just sum of these two fractions and your job is done. So this is a very interesting way of solving this kind of a question. Now there is another question. I have got a request from Gunjan. She's from New Delhi, and actually I have many students with this name. What she has requested is an interesting question. She has requested me that n into n plus 1 into 2n plus 1, if n is an integer, then which of the option will be correct? Then which of the option will be correct? So here it's a very interesting thing. If n is an integer, let n equal to 1. So 1 plus 1, 2, and this is 3. So this is 6. So if this thing is happening, so this part is divisible by 6. Put n equal to 2. 2, 3, 5. So this one is still divisible by 6. Put n equal to 7. 7 plus 1, 8. 7 to 0, 15. Is it still divisible? This is 8 15s. So if I just divide by 6, 6, 3 2s are 6, 3, 5, 4. So it is again divisible by this. So it must be divisible by 6, which is the option C. Now, the other two things, like is it a perfect square? It's not a perfect square. If you just do it, it will be a cubic part and cannot be expressed as a sum of squares. So it's not a square. Is it an odd number? That is not possible to say, and does not necessarily have any foregoing properties. The D is also nullified because C is here correct. So hope you get your answer. Okay. Now there is another question. I have a request. Now this is the request of Franch. Okay. So here x plus y plus z plus w whole to the power 10, and what are the number of terms in the expression? So how many terms are there? So there is a basic formula for this. If a1 plus a2 dot 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 an whole to the power m is given, then the total terms in this expression is m plus 1 minus 1 c n minus 1. That's it. So here what you can see, m is 10, n is 4, minus 1c, 4 minus 1, this is simply 13c3. So once you know the formula, it becomes so easy to solve. Hope you get your answer. In the next video, I will solve many more questions. Keep tuned. And do subscribe so this will be easier for you to get my next videos.